In this video, we're going to see how to prompt the user for some information by using a swing component called JOptionPane. So JOptionPane allows us to ask the user for information or ask the user a yes or no question or give them a predefined set of lists. Here are some of the big features of JOptionPane. showInputDialog will generally get a string from the user, and it's one we've used once before. A neat addition to this is that you can give JOptionPane a predefined list of answers by giving it an array, and it will show a drop-down box where the user can pick one of those answers. That makes it a lot more efficient because you don't have to worry about the user mistyping or anything like that. Also, showMessageDialog shows an informational message to the user, and then showConfirmDialog will show a yes or no button, or you can make it yes, no, cancel, okay, cancel, any kind of combination like that, where you need to ask the user for some kind of confirmation. Now, JOptionPane by definition requires a bit of typing. So I strongly recommend that you, if you do this a lot, that you set up a live template. And I've previously created a video to show how to create live templates for JOptionPane. Live template is something like when you type SOUT and then hit tab, it fills out system out println for you. So because JOptionPane showMessageDialog can be a lot of typing, that's one that is a good candidate for a live template. Before we get started, I do want to do a little bit of housekeeping. In a previous video, we made a class diagram for our application, and we found that the application doesn't totally match. So the main class I need to rename to driver. A simple right-click and refactor does that for us easily. Now drive, I need to rename that to display output. You see, when I do it through the refactor tool, as I rename the method, it renames the method calls on line 35 and 36 as well. So it keeps everything in sync quite nicely. Now I have a whole bunch of stuff in main method, and this should be in a method called promptUser. So you see once again an easy refactor here. I simply take a lot of that logic, put it into a new method, and then I invoke that method from main. The functionality is still the same, it's just been reorganized to be a bit more efficient. Now if we take a look at promptUser, we see that it is hard-coding the values of several vehicles, which isn't very useful because we're always going to be running with these same vehicles. So first of all, let's see how we can prompt the user for each of these inputs. We see that we need an int, a double or float, and an int, and we know we have some live templates set up for this. So note the one I set up, JOPI, if I hit tab and expand it, it prompts me for something and then converts it to an int. So if you see the prompts there, I filled out a temporary variable to hold the string, I gave it a prompt that the user will see, and then I store it into an int variable called miles per gallon. Now instead of hard-coding 20, I can simply use that int variable. It'll be very similar for gallons of gas, only this time we're looking for a double, so I'll use my double shortcut. JOPD is the one that I set up for double. Once again, you'll see that it will expand, and if you just type this out from scratch, you get the same result, but by using those live templates, I'm able to hit just a few letters and it expands for me. I'll stop talking about live templates and just assume you know from now on, but nonetheless, here we go. And once again, I have a temporary string variable called str gallons of gas, and then I convert that to a double, and I name that variable that stores that double, gallons of gas, and I pass that in instead of hard coding it. One more to go, and that is the odometer. For this, we're simply going to use our JOptionPane that returns an int. Give that variable name odometer, and we'll pass that in as a variable. Now, if we take a look at our program, we're prompting the user for information for that first vehicle, and then we have two more vehicles that are hard-coded. And we know that one of the things we want to do here is remove that hard coding to make this an actual flexible program. So what I'm going to do is delete those two hard-coded vehicles because that was really just test data. But I still want to give the user an option to create multiple vehicles. So what I'll do is go with our one that's parameterized, and I'm going to put that into a do-while loop with the JOptionPane showConfirmDialog so that we can keep prompting the user and the user can continue to add vehicles until the user says, no, I'm all finished adding vehicles. As a matter of fact, I'm going to rename this from my vehicle to simply vehicle with a lowercase v. And once again, it changes universally anywhere that variable is referenced. Now remember how a do-while loop works. With a loop, we typically have a test. And once the test resolves to false, the loop stops executing. what makes a do while loop interesting is that the test happens at the bottom. So the loop is guaranteed to run at least once because that test is not evaluated until the end. So we'll start a do while loop with the word do and an open curly. And then at the bottom of where we want to iterate, we will close that loop with a closed curly and we'll say while, and then our test goes in the parentheses that are here. Now ideally we can use the JOptionPane showConfirmDialog to ask the user if he or she wishes to go again. Now this is where those live templates really work out well, because the JOptionPane showConfirmDialog is a lot of typing. We have to declare a variable that's going to store the value that the user entered, and then we have to have JOptionPane showConfirmDialog. Null is the parent component because we're running essentially command line, so we don't have a parent frame to attach it to. Then we have a message that the user is going to see, and we have a title on top of that message, and then we have what buttons the user wants to see. So here I'm saying yes, no option. There's also, I believe, a yes, no cancel or an OK cancel. So several different flavors you can have here. And then an icon that the user will see. Now, couple of notes here. This is really super tricky if you're not used to it. But remember what variable scope means. Variable scope means that a variable is alive from the point where it is declared until the closed curly of the block where it is declared. So if you look here, we have a variable called go again, which has a very short life, because it's only alive in the area that I've highlighted. We know it's declared right here on line 36, but it actually goes out of scope on line 37. This is not very obvious, but can be a real pain if you're not expecting it, because that means we can't use the variable in this while loop test as it is right now. I can't. What I want to do is say, well, go again, equal JOptionPane yes option, which means that the user chose, yes, I want to go again. But I can't do that because you see it's out of scope. So I have two options here. One is to take this entire JOptionPane and throw it right here and just eliminate the go again variable altogether. Another option is to give this go again variable a bit grander scope. So I'm going to change line 36 from declare and initialize the variable to simply assign the variable. Remember, initialization is the very first assignment, so initialization essentially is an assignment. So I'm going to change that to just an assignment statement. And before the do loop, I'm going to declare the variable, but I don't want to make it final because final means it won't change. I'll go ahead and initialize it to no option. And now we see the variables in scope, and it's going to prompt us and say, do you want to continue? And also notice that we're adding the vehicle within the loop, so every time we loop, we're going to get one more vehicle in this collection. Oh, by the way, important note and a common newbie mistake. It's very important that we are declaring this variable vehicle within the loop, not outside the loop. Because if we declare it in the loop, every time we iterate, we will get a brand new variable, and that new variable will be put into our array list. If we declare it outside the loop, the variable is only declared one time and it's continuously reassigned. So we end up with the same variable in that array list over and over again. It probably will make more sense if I walk through it in the debugger, but nonetheless, just a bit of a caution on that. So that yes, no option we want to declare outside the loop, but the vehicle we want to declare inside the loop. So far, I think we look pretty good. What I might do is one more change since I'm refactoring. We know we start with main goes to prompt user. Prompt user is now asking the user for information to fill out these vehicles. Then it manually invokes display output with a couple of hard-coded values. But here again, we're trying to get away from hard-coding. It would be better if we didn't make these hard-coded. So I'm going to remove the call to display output from here entirely, from prompt user. I'm going to change display output to not take a parameter. Now, up in the main method, after prompt user, I'm going to call display output. In display output, just like we did our loop above to create vehicles, I'm going to create another loop to prompt how far we want to drive these vehicles. So once again, and this time I'll tell you what, I'm going to do the while loop a little differently. Up above, I prompted for the confirmation, saved it to a variable, and then tested that variable. Down below here, I'm going to just put it all in one line so I don't have to worry about declaring that variable go again. in the right scope. Both will work the same way. I just want to show you two different ways to do the same thing. I had to do just a little tidying up from my live template because it added a couple things there that I don't need here. But what you see here is we're showing the user a confirmation dialog. We're asking, do you want to enter another trip? Go again. And then we're comparing whatever the user picks with JOptionPane.YesOption. So JOptionPane showConfirmDialog will show a series of buttons, yes, no, cancel, OK, cancel. Each of those corresponds to a number. That number is stored in a variable in the JOptionPane class. And here we're saying, okay, if it's equal to yes option, that means that the user wants to go again. Anything else the user wants out of this. One more thing that we need to do, and we'll do this within our do while loop, is we need to see how far the user wants to go. And that's going to be an integer because the go method accepts an int for miles driven. We know we have a live template for this, JOPI. And with that, we now have a compiling program. What I'm going to do is run it just one time to make sure that it works according to our business case. After that, we can slow things down a little bit and look at it in the debugger. What's the name of the vehicle? Miles per gallon, we'll say 20. Gallons of gas, we'll say 25. Odometer, we'll say 20,000. Do you want to enter another vehicle? We'll say yes, so notice that's our confirmation dialog. Nickname of this vehicle, my electric. We'll save that. Let's just say my car. Let's not worry about electric just yet. My car. Miles per gallon, we'll say 30. Gallons of gas, we'll say 13. Odometer, we'll say 30,000. Do you want to enter another vehicle? This time we'll say no. How far do you want to go? So let's say we want to go 100 miles. And you notice our output here. We have our first vehicle, which was the 20,000 odometer and 25 gallons of gas. After running 100 miles, the odometer is 20,100. Gallons of gas is decreased by 5 because we gave that one 20 miles per gallon. For our car, the odometer went to 30,000 to 30,100. Gallons of gas went from 13 to 10 because we gave that a miles per gallon a little bit higher. What do we call that one? I think 30 miles per gallon. So it looks like it did a bit of rounding or truncation there, but nonetheless, that's what we have. Now remember, we're in our display output loop now, and so it's prompting us if we want to take another trip. I'm going to go ahead and say yes. This one, we're going to say we want to go 60. And it's going to take the existing state of the vehicle, that is 20,100 miles or 30,100 miles, add 60. It's also going to take the current state of the gallons of gas and decrease the amount of gas it took to go 60 miles. So you see our odometer went from 20,100 to 20,160, 30,100 to 30,160. Gallons of gas in the first vehicle from 20 to 17, in the second vehicle from 10 to 8. And now I'm going to say I do not want to take another trip, and the program is effectively finished. So we see that sure enough it does run as we expected it would run. So now I will snap a few breakpoints so that we can look at this in our own pace in the debugger. I'll put a breakpoint in both the prompt user and the display output, and we'll take a look at this at our leisure. You can use these buttons down here or just use the shortcut key on your keyboard. Remember that step over or F8 means execute this line as it is and go to the next. Where F7 or stepped into says if I'm on a method call, go ahead and step into that method. We'll likely use a combination of both. Since println is not a method we want to step into, F8 makes the most sense here. Now prompt user we do want to step into, so I'm going to choose F7. And we see we get our system out print line. By the way, that's a bad habit to get into, system out print lines. I had it there to demonstrate a concept, but that's something we really want to clean up in a program. If we really need to do some output, we can do that with logging. Print line is not the right way to do that. Okay, go again is that variable we declared earlier for our confirmation dialog. So you see we're setting that to the value of the no option, which is some number. It doesn't really matter what number it is as long as it's consistent. In our case, that number is 1. Now we continue to iterate, and it gets a little tricky as I'm debugging because sometimes the prompt doesn't show up because it thinks I have focus on the IDE, but nonetheless, my truck. Now we're going to create our new vehicle. Let me go ahead and do an F7 to step into this. And we'll see it goes to the vehicle constructor that I made, and it initializes all of the attributes for that vehicle. Now miles per gallon, we're going to say 20. We get that as a string, we convert it to an int, and then I'll choose F7, and we can see we're invoking the setter method of our vehicle class, the set miles per gallon setter method. Remember, setter method is used to set the value of an attribute of an object. It's typically like a gatekeeper instead of just assigning the value to that attribute directly. Next, enter gallons of gas, so we'll say 20.0. And once again, do the conversion. F7 to step in as we watch. It invokes the setter method for set gallons of gas. Finally, odometer, we say 20,000. And once again, we can step in and we can watch it set that odometer value. And then it adds this vehicle to our collection of vehicles. So if we take a look down in the debugger right now, we see that we have a single vehicle object. Now let's take a look at all vehicles. And you see that this is a collection with size 0. But watch what happens as soon as I choose F8 and tell this line to execute. It takes that vehicle that we created and it adds it to this all vehicles collection. And now we get the option to go again. I'm going to go ahead and say, yes, indeed, I do want to create another vehicle. So watch as I choose F8, watch the line numbers here. I'm going to go from line 39 all the way up to line 22, which is where our loop starts. I'll go through this part a little bit quicker because we've already seen it. Add a second vehicle, so this time I'll say no, I'm finished creating vehicles. Now watch as we go exit the loop. We go back to the main method and we go now to display output, where that is my output method. So now, how far do you want to go? We'll do our first trip at 100. It looks like it just got 10 there, but you know what? Hey, it's the debugger. Nice thing about the debugger is I can change the value live and do some what-if analysis. So I hit enter a little bit too soon, but I can still come down here and change the value to 100. Debuggers are awesome, by the way. Now we're going to loop over every vehicle that we started above, and we're going to run it 100 miles and then print the output. Remember, we created 2 vehicles, so we're going to loop 2 times. Finally, do you want to take another trip? We'll say yes. This time we'll say 60. Slow it down a little bit here so we can watch the go method. Now the go method operates on vehicle, but remember we actually have 2 vehicles, right? We have the truck that gets 20 miles per gallon and the car that gets 30 or something like that. So watch carefully as I choose F7. We go into the vehicle class and notice it does our computation on miles driven as 60. Now it's going to act on the value of the variables that currently exist in this class. So this is our truck. It has 20 miles per gallon, 15 gallons of gas, and 20,100 on the odometer because it's only run once. What I want to point out here is that this is not a static method. This is an instance method, which means it doesn't have that static keyword. And what that means is that when we invoke this method, it's going to work on one and only one object. And in this case, it's operating on our truck. So it's going to change the values of the attributes of only that truck right now. Now, when we go back out, we loop again, then we're going to do this on the car. But because this is an instance method working on instance variables, anything that we do here is only going to affect the truck. It's not going to affect any other object of type vehicle. So we'll go ahead and tell it to run, and we'll do those computations. And then we print that out. Now, when we loop again, we're going to go to this go method again. But take a look this time. In this go method, we'll look at the value of the attributes of this vehicle. We see 30 miles per gallon and 10 gallons of gas because we've already gone 100 miles. And 30,100 on the odometer because we've already gone 100 miles. So once again, the values that you see right here are for the vehicle, not the truck. And when I run this computation in the go method, it's only going to change the value of the attributes of the second vehicle that I created, the car, not the first vehicle I created, the truck. And that's how objects work. Now, I'm satisfied with what I've seen, so this time I'm going to say no, I don't want to take another trip. And that will effectively wrap up our program, take us to the main method, which is essentially where the program starts and the program ends. So I'll simply say continue, and our program is complete. So with this, I'll commit and push this to GitHub so that we can see these changes in isolation of the other changes. And you can see the message I've entered here, refactor main class to driver, prompt for values instead of hard coding, iterate over new vehicle and number of trips. I'll do a commit and push, and once again push. And if we take a look at GitHub, we can see 7 commits, including refactor main class to driver. And you can see here, Well, actually, this one's kind of weird because I renamed it, so it just shows one removed and one added. But nonetheless, you can see all the changes that I did here. So what I'd recommend is clone this project at that commit, snap a breakpoint, and walk through it. That's probably going to be the easiest way to kind of rehearse a little bit of this. And if you want, try a few different things. Maybe try a different prompt, or maybe add a new attribute to vehicle and try to prompt for that. But that will give you a lot of very valuable experience with the debugger. So as always, I hope this video was helpful, and I look forward to reading your comments. Thank you.